Hello, welcome again. We are solving some questions of thermal engineering. The topic is gas turbine. Question number 1185 from gate 2017 ME-01 is air contains 79% O2 on a molar basis. Methane CH4 is burned with 50% excess air than required stoichiometrically. Assuming complete combustion of methane, the molar percentage of N2 in the product is. So now first of all, considering stoichiometric reaction. A stoichiometric reaction is one that doesn't contain excess of oxygen or excess of O2. Okay. So end products in the stoichiometric reactions are H2O and CO2 and nitrogen. Okay. So this is your stoichiometric reaction of methane CH4 plus 2 bracket. This is your air O2 plus 79 by 21 N2 by volume. This is a fraction of N2 in comparison to O2. Okay, we are considering that only on2 and N2 are present. Okay, so the products are 2H2O, CO2 and 2 into 79 by 21 N2 and N2 go unreacted. So whatever fraction is in the reactant, that same fraction comes out in product. Okay, so here the N2 will be 2 into 79 by 21 N2. Okay, and this O2 gets reacted with CH4 and form H2O and CO2 in stoichiometric reaction. Okay, so when 50% excess air is considered, then we will take here 1.5 or because 50% excess is there, so we'll take 0.5 plus 1 or 1.5 of air. Okay, and this thing will remain same, that is 2H2O and CO2. And now as nitrogen is unreacted, so its quantity will change. So it will be here now 3 into, initially it was 2, now it is 3 into 79 by N2, 79 by 9 by 21 N2, and there will be excess oxygen because here there are 3 moles of oxygen and 2 moles are used in stoichiometric reaction. So 1 mole will be unreacted or free. So 1 free mole of N2 is, oh sorry, O2 is there, and number of moles of nitrogen are 3 into 79 by 21. Okay. So now the moles of nitrogen is 3 into 71 9 by 21, and total number of moles in products are 2 plus 1 3 plus this plus 1. So percentage of nitrogen molecules are, or nitrogen molar or molar percentage is this by summation of this 2 plus 1 plus 1 3 into 79 by 21 into 100, so that is 73.83%.